Can you all see my screen now? Hello, guys. Can you all see my screen?
Yes, teacher.
All right, good. Thank you. All right, we're gonna start first with the uh. Okay, I'm gonna follow the order of the file that I have here. So the first one is the test of 2017. Um. All right, I'm gonna open your response. Wait for me just a little bit. I'm gonna take a look at all the response of the request from 2017. All right. So, okay, let me double check one more time before we start. The recording is here. Let's share the screen. Okay, good. Because this is just to give you the answer and explain, so I'm not gonna ask you the question, all right? If you are unsure about anything else, you can just let me know. All right, other than that, I'm gonna give you the answer right away. Okay, the first question that first question that I got was question number 8. Question number 8. Mhm. All right. So we have the setup. Carbon dioxide is a colorless gas. It denser than air, soluble in cold water, puts out flames. Carbon dioxide gas can be made in the laboratory by mixing hydrochloric acid. Okay, hydrochloric acid is HCl, right? HCl. In the aqueous state, and you let it react with calcium carbonate, which is CaCO3. Okay. For those who haven't learned how to name the compounds, um, well, it's pretty hard for you a little bit for the exam, but I'm gonna try to push you because some of you have already learned how to name the compounds, some of you have not. So I'm gonna push you a little bit. Um, so we have this reaction, and this is what we call a double replacement reaction. So basically, um, the cation from the first compound will combine with the anion in the second compound, and vice versa. So what we can collect is calcium chloride in the aqueous state, um, H2CO3. All right, and H2CO3 is a very unstable compound. It can decompose into water and CO2. Okay, so this is the reaction that we have. Okay, so we have a tube to kind of like deliver the carbon dioxide onto the other side. And here you put a lighted match. So remember that CO2 will not sustain the flame and therefore it will put out the fire. How will the student know when the jar is full of carbon dioxide? The air will go milky. There will be a loud popping sound. The match will go out, and the match will suddenly flare up brightly. Okay, the air will go milky. This is incorrect. It only goes milky when you form something else, not carbon dioxide, because according to the information that you have, it's a colorless gas. All right, it's a colorless gas, and therefore, it will is not going to go milky if you just form carbon dioxide. Sometime when you burn like coal, charcoal, or something like that, and you see that the gas goes milky, goes really cloudy, that is because you form something else, not carbon dioxide. You can form carbon, all right? You can form carbon, and carbon is a solid. All right. So if you have very finely powdered solid like carbon in the air, it will make the air look like it's really cloudy. But well, actually, carbon dioxide is not cloudy. Carbon dioxide is colorless, so you don't actually see anything here. And because this does not sustain the flame, so it will not flare up the flame, or it will not give you a popping sound. A popping sound is like an explosion, because when you burn something in air and it explodes, then you have a popping sound or it flare up. This is for oxygen, right? Because oxygen can sustain the flame. The popping sound is for hydrogen. Okay, so those things are not correct. The only option that we have is the match will go out. Why is that? Because carbon dioxide is heavier than air. I'm not sure whether you have learned how to calculate the molar mass of the compound. Some of you may have learned it already. Some of you may not. So carbon dioxide, we have the molecular weight of 44 AMU. All right. Okay. When you want to compare it to the to the density of the air, the density of the air is the average density of the air is 29. All right. So if it's heavier than the air, the value is going to be higher. So here, 44 is higher than 29. Then carbon dioxide is heavier than air, and it is also provided in the information that you have. All right. So because it's denser than the air, when you deliver carbon dioxide into the jar, it will stay at the bottom first. Okay. And then when you fill the jar with carbon dioxide, it, it's just like when you fill it with water. It's just this time you don't see the gas because it's colorless. However, when you deliver more carbon dioxide, it will still give you more carbon dioxide into the jar until you reach to the very top of the jar. And then at this point, you have the lighted match. Remember that carbon dioxide will not sustain the fire, and therefore it will um, put out the lighted match. So let's see. Okay. Moving on to the next question. Question number 9. All right. We have this system, which this is what we call the titration. So the way that a titration works is that you're gonna have some reactant down here. All right. And in the burette, you also have another reactant. So it's gonna be like A plus B to give you something. All right, to give you something, give you COD. All right. And the way that titration works is that these two gonna react together at the end point. All right, at the end point when A reacts completely with B, we're gonna see some kind of change um, in the flask out here down here to signify that the reaction has been finished. Okay, so it's gonna be A plus B something to give you COD, and at the end point when you form when you have a complete reaction, it's gonna have some kind of observation down here. You can use the indicator. The indicator means when A or B is in excess just a little bit, it will change the color. That is the indicator. Or what you can also see is that maybe A or B has color, but C or D do not have color at all. All right. So when A or B is in excess just a little bit, you can see the change in color. All right. So that is the titration. Titration is a technique that is used to determine the concentration of what is inside the flask by using a no solution with no concentration. All right. So in the burette, you're gonna put a solution with a no concentration. Let react with the solution in the flask. And down here, you have a certain volume. Up here, you use a certain volume. So you have volume, you have concentration, volume, concentration. Then you can calculate the number of moles. And then because you know that at the end point, these two will react completely together. So the number of moles of what is inside the burette that you used and the number of moles of what is inside the flask, they are going to be equal to each other. And that is the principle of the titration. Okay. Okay, so now I we have to read the volume that is inside the burette. All right. So when you start reading, okay, you're at this level. And the way that a burette works is like this. The initial volume. So for example, like if you fill up the solution up to this point, okay, and after the reaction you use up and you have this. Okay. Initially you have this. I mean the height of the solution inside the burette. All right. Initially you have this, and after you use up, you have this. So you see that we actually use up this much of solution. All right. So we are not going to use the whole burette, but you use this much of solution in the burette. So it's very easy. You just take the initial, sorry, you just take the final reading minus the initial reading, right? It will give you the volume solution that you actually used. Okay, so you have the final reading, you have the initial reading, okay, and then for every single mark, it's gonna be corresponding to 0.1 milliliter. So here you have 9, so it's 9.1, 9.2, right? So at this point, you have 9.2. So you start the reaction at 9.2, and you end the reaction at, okay, here 20 is one mark above 20, so it's 19.9, right? 19.9 minus 9.2. And the answer is, sorry, 9.9, not 19.2. 19.9 minus 9.2 is going to be 10.7, right? So the answer is B. Okay. Question. Yes.
The reading before Y is 9.2. I think it would be 8.8.
Oh, okay. The way that the Burette work is that the lower that you go, the higher the value is. You see, the number 0 is at the top, and the number 10 is just below 0. So on and so forth. So the lower that you go, the higher the value will be, and the higher that you go, the lower the value that it will be. Okay. All right. Good. All right. You can take a look at the burette again. You can see here if you zoom in a little bit more. Burette is designed this way. All right. Remember, for me, burette is designed this way. The lowest number will be at the very top. If you go into the lab, you're gonna see that we do not have the volume 0 at the bottom. No, no. Burette is designed this way. At the top, it means you have volt 0, so that it's gonna be easier for you to do the calculation. Okay, so that's the reason why it's designed to have 0 at the top and the final volume at the very bottom. Okay, let's move on. All right, we will move on to question um 12. Yes, 12. Question number 12. Question 12. All right, here we have the table. We have many different food. We have the amount of tryptophan, and we have the amount of protein inside that food. Which statement is most true? Okay, most true. Question number 12. Generally, the more tryptophan a food has, the more protein it has. Okay, let's see whether it's generally, all right, it means that it's correct, but not entirely correct, but generally it's correct. All right, so 0.01, you have 1 gram of protein. You increase it, and it increase, increase, more protein, increase, more protein, increase. It's a little bit lower, okay, and you increase. So generally, it's correct except for pork. All right, generally is correct. Okay. Soybean generally contain more tryptophan than fruit and meat. Soybean, okay, here contain more tryptophan than fruit and meat. Fruit. Uh, oh, sorry, less. The statement is less, not more. But soybean is the top when it comes to the amount of tryptophan. So generally, it contain more tryptophan, right? So this is incorrect. 300 grams of milk contain more protein than 100 grams of egg. All right, milk is here. 300 grams of milk contain more protein. Okay, so this is the amount of protein in 100 grams of milk. So if you want to calculate for 300 grams of milk, multiply by 3, right? Multiply by 3. So you have 9.6. So you have 9.6 gram of protein over here. Okay, let's take a look at 100 grams of egg. Egg is here. 100 grams egg contain 12.6, which is more than 9.6. So this is incorrect. This statement is incorrect. Soybean contained 4 times that much protein as eggs. Soybean, okay, soybean is here. The amount protein is 36.5, and egg is 12.6. This is 3 times. This is not 4 times. All right, this is 3 times, not 4 times. So this is incorrect. So the answer here is A. Okay. All right, that's question number 12. Okay. All right, moving on to the next one. I think the next one is 14. Mhm. Question number 14. Okay, Pokeball. All right, Pokeball is one of the what the other top. All right. Sorry, I'm a fourth. I'm a fourth. Allotrope. Sorry, Allotrope. Sorry, I missed. I was confused with another term. All right. Buckyball is an allotrope carbon. So for carbon, we have many different type allotropes. We have graphite. We have diamond. Um, if you don't know what they are, like the allotrope, the structure of buckyball or graphite or diamond, I recommend you to take a look at the book, the ICC book in chapter 3. All right, in chapter 3, take a look at the allotrope, the term allotrope, and some of the allotrope of carbon. So it's like the way that we arrange the atoms in the element state is a little bit different between many different samples. Okay. So blah blah blah. All right, which one could represent the volley here? Okay, in 2016, you, we discover a new hollow case make up 20 Scandinavian atoms and 60 carbon atoms. It is hoped that volleyball can be used in electronics and chemical catalysis. Okay. So they ask it, like, which one will represent the volleyballing? All right. The first one, if you take a look at the book already, this is buckyball. First one is buckyball. We have 60 different atoms of the same kind, right? Because you see, they have the same color. So they have 60 different um, atoms of the same kind to form a bowl, just like a bowl, right? C is actually the structure of what we call an ionic compound. It does not have the spherical shape like thing that is in the illustration. This one as well does not have the spherical shape, and also you see they have the same type atoms because they all have the same color, right? They all have the same color, so they have the same type atoms. However, the thing that we have to choose, which is volley, they have two different types of atoms, right? Carbon and Scandinavium, and it has the shape of a sphere. So it's B, right? You see, we use two different colors to represent two different type elements. And you can see that we have the color pink and the color gray. So the color gray, we have a lot of gray atoms. So basically that they are carbon atom and scandium atoms. They have the color pink. So that's the reason why we have B, all right? Two different atoms and they have the shape of like a bowl. Okay. That's question number 14. Question number 16. All right. Question number 16. Bilon is a type alloy. Okay, so we have alloy, and then we have copper, we have silver. If some of the coins were melted down and make into an Olympic side metal, okay. Okay, we to do this question, we have to take a look at the information in question number. Okay, let me see where do we start? Okay, okay, it's gonna be from question number 15 as well. Okay, question number 15. Um, okay, we do the calculation then. Now we need to calculate the amount of copper, the amount of silver, and then multiply it by the money that we have. Um, okay, so we have three different metals. The gold, blah, 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 is equal we make Olympic side medal. Okay. Mhm. Olympic side medal, blah blah blah, means gold. Mm, This. Okay, so based on the information that you have here, Mhm. Based on the information that you have here. Okay, when you have like 95% of copper and 5% of zinc, all right, it will cost you, it will was around $4, right? It was around $4. So it means like when you use 100% copper, when you use 100% copper, it's gonna cost you a lot, a little bit less than $4, maybe 3.9, all right, because we have some zinc as well. So if you just have, sorry, it's gonna, sorry, um, we can, what we can assume is that, this is almost 100% already. This is almost 100% copper already. So you can assume, okay, 100% copper will cost you around $4. Uh-huh. You can assume that it close. All right. The other metal that we need to also use is silver, right? Okay, silver. Um, when you use only silver, it's gonna cost you $435. All right. When you use just silver, which is 100% silver, it will cost you around 435. Mm-hmm. 435. All right. So you now have, the price, and now we move on to do the calculation. Okay, let me open my calculator. So 435 multiplied by the percent of silver, which is, all right. Uh, when you have 100% silver, all right, based on the information that you have, it will cost you $435, right? Now you just use 40%. So 435 multiplied by 40%, right? And you add the price of copper. When you make the metal completely from just copper, it will cost you $4, roughly $4. I know that it will have some zinc, but we can assume that because the amount of copper now is almost 100%, so we can assume that. Okay, four times 60%. Okay, and you add up everything together. Okay, and then it will give you the number of 176.4, which is roughly $180. Okay, so that the answer is B. Question number 16 is B. Okay, moving on. Um, Question number 17. Okay, question number 17. Okay, we have this. We have the amount of sucrose. Sucrose is just like the sugar. The solution is unsaturated. Unsaturated means you can dissolve more solute. All right. When it comes to solution, we have two different terms, which is a solute and a solvent. All right. For example, like solute is like salt. So it's like sugar. All right. The thing that you dissolve in what we call solvent. Solvent can be water. Okay. You dissolve salt in water. So solute is salt and solvent is water. Unsaturated mean you you can dissolve more. All right. You can dissolve more. So you can add, if you have an unsaturated solution, you can add more salt to it and you can still dissolve it. But if the solution is saturated, it means you cannot dissolve more. If you add more and you stir everything up, the solid will stay at the bottom. It cannot be dissolved in the solution anymore. And uh, inside here we have, um, the supersaturated form and the saturated form. Supersaturated is when you dissolve a lot of compound inside the solution and then you lower the temperature down. Then your solution now will become supersaturated. It means it has more solute than the capacity that it can contain, right? Because the lower the temperature goes, the lower solubility will go. Okay, so imagine like at high temperature you dissolve a lot of salt, all right, but when you lower the temperature, now the solubility will go down and then you cannot hold that much solute in the solution anymore. Then it will give you the saturated state, and then you will have what we call the crystallization process. All right, the crystallization process will return, All right, it will eliminate some of the dissolved solute back to the solid state again. All right, it will revert the dissolved solute back to the solid state again, and then you have crystal. All right, you have crystal that is separated out the solution, and therefore you have solid at the very bottom of the beaker, and also the solution now will come back to the saturated state. All right, it will eliminate uh, the redundant part that it cannot dissolve anymore, and then the solution now is sat is saturated. It will only contain the maximum amount of solute that it can contain, and it will eliminate out the solution the amount that it cannot contain anymore. Okay, so it's just like when you're hungry, all right, and you eat a lot. So when you're full, you are saturated. But if you eat too much, more than the amount that you can kind of digest, you are super saturated. All right. And because you cannot contain that much food, you will vomit. So you will vomit until you kind of like empty um, the superfluous amount of food until you become the saturated state again. All right. So that is roughly the example that I can give you. All right, the different solution of sucrose was given to a student, and then the student, when a small crystal of sucrose was added to the solution, is dissolved a little bit stir. It can dissolve. All right. Now, when you have a solution and you add more sucrose to it, it still dissolves. It means the solution is unsaturated. All right. When you have an unsaturated solution, you can dissolve more. Because if you have a supersaturated or a saturated solution, basically if you add more solute into it, it cannot dissolve. All right, it cannot dissolve because it's too much already. All right, moving on to question number 19. Yeah, question number 19. All right, we have these compounds with the color. The information about suggests that sulfate, um, okay, cause it to be blue. All right, copper sulfate is blue. Nickel sulfate is green. So sulfate does not cause the color to be blue or green. This is incorrect. Cause it to be green. No, because copper 2 sulfate is blue. All right, so it's not. Cause it to be red. No, right? Nothing is red. Oh, we have copper sulfate is red, but like we have nickel sulfate, which is green, and copper sulfate, which is blue. So well, it will not determine the color, right? Based on the information. If sulfate controls the color of the compound, then copper sulfate, nickel sulfate, and copper sulfate must be red, right? But in this case, you see that they all have sulfate, but they have different colors. So probably the thing that controls color is not sulfate. Um, okay, that's the question 19. Moving on to the question number 21. All right, this is what we call filtration. Okay, filtration. Okay, colorless mean without color. The mean clear means not cloudy. All right, without color and not cloudy, they are different. All right, colorless is when, for example, like you can see through the solution even though it has color. For example, like wine. Why sometimes you can see the color of yellow or pink, right? You can still look through the wine. It's just that it has color of yellow or pink. All right, that is colored. Not cloudy is when you can see. So clear is like when you can see through it. All right, it doesn't. For example, like milk you cannot see through, so it's not clear, right? When you have milk, you cannot see through the solution, obviously, so it's not clear. However, when you have water, you can see through it, so it's clear. All right, it doesn't really matter whether you have color or not. It's just whether you can see through the solution or not. Mhm. All right, we have this system here. Uh, all right, you have a blue solid, you have white solid, and you have water. And the blue solid and white solid were shaken together with water, forming a blue, cloudy blue liquid. All right, cloudy blue liquid. And then when you pour it through a filter, only the Y solid stay in the filter. All right. It means the thing that is dissolved will be able to go through the filtration system. Okay. All right. So the Y thing will give the solution. We make the solution cloudy. All right. This is because of the Y solid. It will make the solution cloudy. All right. And through the filtration, you kind of eliminate all the Y solid. So you just have the blue liquid. So you just have the blue liquid. So it's gonna be clear. It's not cloudy anymore because you eliminate everything that is that makes the solution cloudy when you let it go through the filtration system. So it's gonna be clear. It's gonna be blue. All right. It's gonna be clear and blue. So it's B. Question number 21 is B. Okay. Clear and blue. All right. Moving on. Question number 22. 22. Mercury is heavy metal, mixed sodium hydroxide, chlorine, thermometer, blah, 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 mercury pollution, blah, blah, blah. Research at Findless developed an inexpensive polysulfide material by lock in the mercury. Material is made from sulfur limonene. Sulfur is the byproduct, blah, blah, blah. Which statement is correct? Okay, so based on all the information that you have, which statement is correct? Mercury is made by reacting sulfur and limonene. No, that is a material that will be used to kind of like lock in mercury. It's not the process of making mercury. This is incorrect. The polysulfide material is made from sulfur and sodium hydroxide. No, it's made from sulfur and limonene. So incorrect. If the mercury polysulfide material turns dark red, high levels mercury um, remove mercury from solid after binding enough mercury, it changed from dark red to yellow. No, no, no. When you have high level of mercury, it's gonna turn into yellow, right? Based on the information that you have. When you bind to enough levels of mercury, it changed from dark red to yellow. So the final color must be yellow, not dark red. So polysulfide material can only contain 3 elements. Okay, I'm not sure whether this is correct or not, but this is the only option that I have left after eliminating the other options. So it must be the correct one. But let's take a look. Polysulfide contain 3 elements. All right, we have sulfur, okay, and we have limonene. Limonene is C10H C10H16, right? So we have carbon and hydrogen as well. So in total, we have sulfur, we have carbon, we have hydrogen. So 3 different elements. So that's correct. So that is question number 22. Question number 24. Question number 24. All right, Nobel Prize shared between these two people for molecular machine. It's a machine in on a very small scale. All right. uh, Breakthrough where they use a copper ion, a copper that become chain to construct two link between a molecule chain before jumble up the part of sequence construct the link in the chain. Okay, the order, all right, the order um, for the steps that we have for this one is which one is the correct one. Okay, so let's read through it. Use copper to construct two links before jumble up, the part of the sequence is constructing the links uh, in the chain. Okay. So, okay, the Q must be the final one because um, because this is the final product, right? Um, Construct two links in a molecular chain, right? You have two links in a chain. So this is two links in a chain. This must be the final thing, the final step. Okay. So Q is going to be at the bottom. Moving on, we have copper. Copper before jumble up. The part of sequence is constructed to link the change, and then basically you use copper to kind of induce the interaction between two different molecules. So copper here, which is copper, it will get the molecule closer to the molecule that you have already here. All right, so R is the first one. And then when you have the first one, you form this kind of complex. Okay, and then you recruit the other half before you have the final product. So R, B, S, and Q. All right, you recruit the first half and then you recruit the second half, and you have the correct order. So, oh, sorry, this is not R, B. All right, R, P, R, P, S, Q. So it's A. Question number 25. Graphene. We have this. Which statement is not true? All right, we have a lot of information. Graphene is better at conducting heat than copper. Conducting heat than copper. All right, we have thermal conductivity. So the higher the thermal conductivity is, the better at conducting heat the material is. However, when you see the word resistivity, it is the ability to resist the electrical flow. All right, it is the ability to resist the electrical current. So the higher the electrical resistivity is, the worse at conducting electricity the material is. Okay, so remember for me, we have two different terms. We have conductivity. So the higher the value of at the conductivity is, the better it can be at conducting heat. But resistivity is ability to resist the electrical flow. So the higher the value of electrical resistivity is, the worse at conducting electricity you are at. Okay. Graphene is better at conducting heat than copper. Graphene is here. Is better at copper than conducting heat. Yes, because it has higher thermal conductivity. All right. Keep in mind that we need to choose something that is not correct. Diamond is better at conducting heat than copper. Diamond is better at conducting heat than copper. Yep, that's correct. It has a higher value of thermal conductivity. Graphene is better at conducting electrical than copper. Graphene is better at conduct electricity than copper. 10. Yep, that's correct because it has a lower value of electrical conductivity. Yep. And the last one is probably the one that's not true. Diamond is better at conduct electricity than copper. No, diamond has the thermal conduct. Sorry, electricity. Sorry, here. Diamond has a very high electrical resistivity, so it will resist the electrical flow. So it can only be copper. It has the lower electrical resistivity, so it can conduct electricity much better. All right, we have come to the question number 26. 26. Pigments are natural or artificial or unnatural or artificial substances. Okay, be colored to the substance. Blah blah blah. All right, which of the following is the color caused by a pigment? All right, caused by a pigment. The yellow of a candle flame, the green of a plain leaves, the red in the rainbow, the blue in the sky. Okay, this is a very interesting question. Well, actually, you have to know a little bit of physics knowledge to be able to answer this. All right, the yellow from a candle flame, that is the color flame. It's not a compound. It's because you excite the atoms and it will emit light. All right, so you need to know a little bit of physics there. So the color of yellow here is not because of pigment. All right, you only have the color of yellow when you light up the candle, right? So it's because when you have flame, you have color, but the color of flame is not the color of the the object. It's not the color of the substance. All right, so A is not correct. Later on, you will know that when you have flame, you are actually exciting the atoms. All right, to excite to the excited state, and when they come back to the ground state, it will give you the light. It will give you the color of light. So this is not correct. Red in the rainbow. This is actually because light is scattered. All right, light is scattered through rims, so it will give you different colors. All right, so the color red is because of light. It's not because of pigment. Pigment is the compound, is a substance that will give you color, but light is not a substance. So is it correct? Blue, the same thing. The color blue in the sky. I think that I actually explained this one before in some of the class in some of the classes, not in all classes, but in some classes. The color blue in sky is because blue um blue color in the sky is scattered more than the other color. So the main reason why you see the color of sky to be blue is because the color blue is scattered more in the sky. All right. This is the same reason why you see the color in the ocean or the color in the swimming pool to be blue, right? If you take just a small amount of water from the swimming pool or from the ocean, it's not blue, it's colorless, right? It's colorless. However, when a lot of water stay at the same time together, it will scatter the blue light a little bit more, and therefore you see that the swimming pool or the ocean appear to be blue. However, it's not because of the pigment, because if you have the pigment, then the color will stay blue, even though you just have a little bit of water in your hand. All right, but it's not. So the answer is the green of a plain leaf, and that is because of what we call the chlorophyll. All right, chlorophyll. Chlorophyll, I think that you probably know what chlorophyll is. Chlorophyll is like a pigment inside the trees that will give the tree the color green. All right, moving on to question number 28. All right, moving on to the question number 28. Concentration is measured the amount of solute given in the solution. For example, sugar is the solute of sugary water, blah, blah, blah. Concentration contain more solute than blah, blah. All right, which is the one that is most concentrated? Concentration will be calculated by, it will tell you the amount of solute in a certain volume of solution. Okay, so you have the mass of sugar and you have the volume of water. So just to calculate the concentration, just take the mass and divide it by the volume. All right. So here, one divided by 50, so you have 0.2. Yep, 0.2 grams per milliliter. All right, so that is the concentration of the first solution. 4 divided by 25 is going to give you 0.16 gram per milliliter. This is the concentration of the solution C. Do the same thing for B and D. 5 divided by 20, 0.25 grams per milliliter, and 1 divided by 10. So it's going to give you 0.1 grams per milliliter. So the most concentrated solution is B, right? 27B. Hmm. All right, moving on to the question number 28 and 30. 28. Ammonia make fertilizer, blah, blah, blah. We have a system to make ammonia from sunlight, like this. All right. The method is realized in the element can be found in the air, being bubbles through the solution where it react with the charged hydrogen particle. Um, what gas is bubble in? Well, take a look. All right. You need to have a gas that from hydrogen it will give you ammonia. So it must have what? So you have to ask yourself, where does nitrogen come from? Right? In the solution, we have sulfate. We have many other things. We have water, right? We probably have water, which is H2O, but we don't have nitrogen. So you must ask yourself that question. That nitrogen must come from something else, and it's come from the gas that you bubble in, right? Because you just cannot just like create new element when you have a chemical reaction. Keep in mind for me, when you have a chemical reaction, it only changes the number of electrons, then you cannot have new elements. All right. So this new element, this nitrogen element, must come from the gas that you bubble in, and you have to choose a gas that have nitrogen. So the only option is nitrogen. Okay. You must provide nitrogen so that you can form NH3 here. Otherwise, you cannot have nitrogen. And the last question is question number 30. All right, we have these what we call ether. All right, ether. Okay, so well, this one is a little bit challenging for you because you haven't learned organic chemistry, but you have to take a look at the pattern. All right, butyl, butyl. These two compounds have the same what? Have the same butyl thing, but different about the part. So you have to compare these two, and you see that the common part is this region here. All right, the common part is this region here. The different is this region here. So butanoate and methanoate will depend on these two regions. All right, and so in the final product you have butylpropanoate. So you want to keep this. All right, you need to choose something that have that part. So you eliminate this one, you eliminate this one. So you only have A or D. Or you can also eliminate D because you see butyl is not in D. So butyl is here, right? So it's A. But you also want to take a look at the other one. Um, so you have ethanoate, you have propanoate, propyl, all right? When you change, when you change this part, it change this region, okay? And therefore, based on the information that you have, propanoate, okay, ethyl is here, um, butyl is here. So it means propanoate is this region. And you keep that region for the first half of the molecule. So propanoate, this part, butyl, that part. So that's how you take a look at the last one. Okay. So we have finished the first file. Moving on to the next one, which is 2016. 2016. Can you give me 1 second? 2016 here. Okay. All right. 2016. I only received 3 response. I'm gonna just take a look at the question that you asked for. All right. I'm not gonna answer all of them. Anyway, for the year 2016, the first one is question number 3. Question number 3. How many different elements in dynamite? All right. Dynamite is here, right? We have carbon, we have hydrogen, we have nitrogen, carbon, hydrogen, nitrogen, oxygen, right? So four. Question number 3, we have 4 different. Uh, oh wait. Oh, sorry. Dynamite also have some other elements here as well. This is just like one of the ingredient in dynamite. Which this is nitroglycerin. So sorry, my bad. This is nitroglycerin. Um, and then we have to mix it with diatomaceous to form dynamite. Dynamite is like the mixture between nitroglycerin and some other thing as well. So you mix it with this thing as well. So what do we have else? What else do we have? We have silicon, we have aluminum, and we have iron. All right. So in total, we have 7 different elements. See. Um, question number 5. Question number 5. Flour, crushing cereal, grains, wheat, starch, protein, some simple bread, flour, yeast, water, salt, making 3 simple. Follow these steps. Okay. So flour added, and then make gluten, then leavening, make add yeast, add salt, um, control the rate of forming carbon dioxide. In the oven, carbon dioxide is spent closely down to expand even further. All right. Damper is a traditional Anatolian form of bread made from flour and water. Sometimes some bicarb soda, sodium hydrogen carbonate, is added to flour. The reason to add this one is to it's have to produce carbon dioxide. See why? Let me explain. Because one of the step is that you need to produce carbon dioxide, right? When you make bread using yeast, it will break down starch to create some carbon dioxide. and then when you bake it, the carbon dioxide will expand, and then it will cause the bread to rise. All right. Now you make with only flour and water. All right. We make it only with flour and water. You don't let you yeast here. So instead of like getting CO2 from yeast, now you get CO2 from sodium hydrogen carbonate. All right. When you heat up, it will return into sodium carbonate and CO2 and water. All right. And will give you CO2 again. So now you do not use yeast, but you still get CO2. So that when you kind of bake the bread in the oven, it will help your bread to rise. All right. And you still have CO2 to rise the bread without yeast. Let's see. Question number 11. Uh, we have this metal, all right, and then animal use blood to transport oxygen around the bodies. The following describe the blood number of different animals. Um, okay, which metal can be found in the blood of each animal? Right, we have to map the color to the corresponding color up here. Um, Human has a dark red to bright red, so it has to be something that is red. So it's iron, right? Red. You see the color red here? It's iron. Human, we have iron. Spider, blue, to clear and colorless. So we have to choose something blue. It can be vanadium or copper, right? It can be vanadium or copper. All right, we're gonna skip that for now. Sea turtle is green, becoming more blue and orange. Uh, so it has to be something that is green. Um, and it can also give you the shade of like orange or blue. All right, so it can only be vanadium. So the color the metal for spider must be blue green. Okay, so because it has the color of orange as well, and also green and blue, so it must be vanadium. And the last one, it has the color of brown. You have to choose something that is brown, right? Which is the first one. I know that we can also have the color brown in the other option as well. However, we kind of like associate that option with the other, animals already. So we got not gonna use a you do not duplicate it. All right. So question number 11 is going to be C, iron for human, copper for spiders, vanadium for sea turtles, and manganese for, the mollusk. All right, moving on. Question number 15. 15. What was collected and placed in beaker 2 after completing step 1? So step 1, step 2. All right. Um, you have a mixture of copper, saving, sand, salt, and styrofoam. Stir a magnet around the mixture and place any substance that stick to the magnet to beaker 2. All right. What was collected and placed beaker 2? All right. Beaker 2 is something that can be attracted um to 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 um to magnet, right? However, take a look. Magnetic is whether you can be attracted to a magnet or not. All right. You see, all the things that we have, copper saving, sand, salt, styrofoam ball, something like that, they are not magnetic at all. So nothing will go to big two because they cannot stick to the magnet. So nothing. All right. Um, 20. Oh, sorry, 17. 17. 5.1 liters of water pure into vapor at 100 degrees Celsius, cool down to room temperature, condensed to give 3 milliliters of liquid water, and it has the mass of 3.0 grams. Which statement about water is mostly to be true? All right. Water vapor is weightless. No, nothing is weightless, right? It has weight because it still have the mass of 3 grams, right? When you condense the vapor back to water, into liquid water, it has 3 grams, so it's not weightless. All right, it cannot like get mass when it condenses to liquid. No, everything has mass. All right, everything has mass. Even the air that you're breathing in, it has mass. All right, it's just whether we can measure it or not. It has mass. Everything that is a matter will have mass. When the water vapor condenses, the molecules move closer together. Okay, that's correct, right? Because we have the condensation process, and you have learned already that when you have the condensation, the molecule will move closer to each other. Mass of water vapor was 5.1 kilograms. No, 5.1 is the volume, it's not the mass. There are more molecules in 5.1 liters of water vapor in the liquid water. No. All right. So they have the same amount of water, right? They have the same amount of water. It's just that the volume of water is different, but the amount of water is the same. So they have the same, not more, but just the same molecules of water. Same amount, just different volume and therefore different density. So the correct here is B. The correct answer here is B. Moving on. 26, 28, and 30. 26. All right, we have this process. Let it be QRSTU represent the process that combination processes, including chemical physical changes. Fermentation is a biochemical process which make alcoholic drinks in P and Y. This chemical reaction, simple sugars are transformed into ethanol. What step uses fermentation? Fermentation is, well, fermentation is a chemical process. Okay, it's a chemical process. So it means you have to have a chemical reaction. It will change something according to a chemical reaction. All right. So it's going to be Q. Let me explain. It's going to be Q. Number 26 is Q, which is option B. All right. All right. Let me explain. Sugar cane to glucose. Um, so the first step is that you're gonna right. If you know how to make sugar cane, you know that the first step is to crush down sugar cane to kind of ooze out the juice. All right. So it's a physical process. You ooze out the juice out of sugar cane. It's a physical process. And then from glucose to become ethanol, well, actually, this is the when you have the change in chemical composition. From sugar cane, you have glucose already, but it's in the tree, and now you extract that glucose into the juice. But now, from glucose, you change into a new compound, which is ethanol. So you have a chemical reaction there. So it must be fermentation. From ethanol here, you convert it into ethanol. So still ethanol, but just in a different form of different physical state. So you can use maybe that step is evaporation or something like that, or fractional distillation to kind of like separate two components. So anyway, this is a physical process to separate things, but we do not change the composition. Second one, crude oil to alkane mixture. Well, you have learned this. These processes are S and T are what we call the fractional distillation. If you do not know fractional distillation is, take a look at um, the book. All right, I'll read the book. I have already taught fractional distillation to some of the class, but not all of you. So the term here for S and T are fractional distillation to kind of like separate a mixture into individual substances. All right, based on the boiling point, based on boiling point. And the last step is, you have the chain from ethene to ethanol. Yes, that is definitely a chemical reaction. However, fermentation is a biochemical process to make beer and wine. It's a and it's in this process, simple sugar is transformed into ethanol, right? Simple sugar like glucose into ethanol. So Q is the answer. It's not U. U is later on you will learn that U is actually the industrial process to make ethanol, but it's not going to be a biological process because we do not use any kind of like living organism to kind of like catalyze this reaction. Okay, so the option here is B. Okay. Basically, based on the information, you can also answer that one. From simple sugar, which is glucose. Glucose is one type of sugar. You transform it into ethanol. So that's correct. Ethene is not sugar, and therefore this is not the fermentation process. Question number 26. All right, finished. Question number 28. Diagram. Limiting reagent in this reaction is what? Okay, so limiting reagent is a thing that will be in excess after the reaction. So you see here, you have X2. After the reaction, you also have X2. Okay, so that is the lim. Oh, sorry, no. X2 is the thing that is in excess. Sorry, my bad. X2 is a thing that is in excess. Um, so the limiting reagent is a thing that will be used up completely. All right, the thing that will be used up completely. So it's going to be this molecule here. You see, we have no trace of that molecule after the reaction. So it's a limiting reagent. So it's going to be XY2 B. XY2, right? You have one atom and two atom of the other elements, so it's XY2. You see, we have no trace of this element of this compound after the reaction. It means the reaction is already used up. The reactant is already used up. And the question number 30. Uh, Solution of potassium iodide, which is Ki, and beaker 2 contain lead nitrate, which is BbNO3, 2. And when you combine these two solutions, you will form what we call the precipitate. It's like the solid that is not dissolved in the solution. All right, we have formed the precipitate, and then you filter out. You filter out the precipitate, and then you have just the solvent again. So it's being bigger 4. So you have to write down the reaction here. What we have here is the double replacement reaction. Double replacement reaction. So potassium will go with nitrate, iodide will go with lead. All right, so we have KNO3 and BBI2. All right, BBI2 is the precipitate. All right, BBI2 is the precipitate because in the future, you know that every single nitrate salt, they are all soluble. All right, they are all soluble. And every single alkali salts, they are all soluble as well. So BBI2 will be the yellow precipitate that you collect at the end. It will be the yellow precipitate that you have at the end of the reaction. All right. So in BK4, it will have the solution of potassium nitrate, which is the thing that is still in the solution. All right. And potassium nitrate, you add a little bit more of potassium iodide, you can still form the yellow precipitate, right? So it means lead-2 nitrates is still in the solution, right? You have potassium nitrate, of course, because of the product. But now in BK4, which is colorless, and now you add potassium iodide, you form yellow precipitate still. It means you still have lead-2 nitrate in the solution. All right, and it can react one more time to give you the yellow precipitate. So you have water, you have uh, potassium nitrate, and you also have lead-2 nitrate. All right, so the answer here is C, right? C, you still have some lead nitrate. That's the reason why when you add more potassium iodide to it, you can still form more product, more precipitate. All right. I finished the second one. And the last one is question number 18. All right, moving on to 2018, guys. All right, question number 1. Um, Demonstrate the reaction between magnesium and hydrochloric acid. Magnesium lead react with HCl. It will give you MgCl2 and hydrogen. Okay. Um, and you have a popping sound. All right. You let it react. You form hydrogen. Hydrogen is really light. It's lighter than air, so it will go to the second test tube. All right, up there. And then when you give it to a splint, a wooden splint, it will pop because you have hydrogen here. Hydrogen can explode when it comes into contact with oxygen, and we have just a light, a splint. It can have this reaction to form water. And this reaction is very, what we call exothermic, very exothermic. It releases a lot of heat. It releases a lot of heat, very exothermic. And then it will give you the popping sound. Uh, Okay, which of the following is a good hypothesis for the experiment? Uh, if more magnesium is used when it make the bigger pop, bigger test tube, more acid you when make a bigger pop and it give a bigger flame, then the gas will make a louder pop. All right, for question number one, okay, we have this. Um, HCl bubbles. The teacher collect the gas in a tube, small piece into a test tube with a small amount of hydrochloric acid, purpose of the gas started to collect the gas in the tube bubble lead. If you use more acid, will make a louder explosion. Okay, so this is the question that we have. If you use more acid, will it make a louder explosion? So the hypothesis. This is the question. You have the question, so you have the hypothesis. So the hypothesis has to do something with the amount of acid and the explosion. So the hypothesis is going to be related to acid and relating to the explosion, which is the bigger pop. All right. So it's C. All right. The hypothesis will give you the your kind of like expectation of what should have been the result uh, to answer the question that you have for your experiment. All right. For an experiment, you have the question and you have some kind of expectation. You have some kind of what we call hypothesis, and you got to do the experiment to kind of like validate whether the hypothesis is correct or not. So that is the answer for the first one. Question. The next one is question number two. All right, which is the least helpful for the experiment? Okay, so for this experiment, we do not need to use this one. This is what we call the ring stand. All right, this is what we call the ring stand. This is only used when you want to heat up something. It's like you have a bottle, you have a bottle here, and you want to heat it up. So you're gonna put it on a ring stand, and you're gonna have some kind of like flame down here to heat up. All right. So you don't really need this. You have test tube. So you put it in a tray, the test tube tray. You have the claim to kind of hold up the test tube. All right. This is the tool that you use to hold up the test tube. The graduate. This is the measuring cylinder or the graduated cylinder that is used to kind of measure the volume of liquid. In this case, it's going to be HCl. All right. So we all use the tools except for the last one. So skip that. Question number seven. Question number seven. All right. Question number seven. Uh, Heads up matches contain a mixture of substances. We have these things, and um, where we need to use friction to kind of ignite the flame. Uh, Once the mixture has been used up, what provide oxygen needed for the match to keep burning? Well, it's basically the air, right? Because you can um, potassium chlorate is the one that will provide oxygen. Yep, here to burn it in the initial place. But if you want to maintain that flame, then you use oxygen in the air. That's it. So it's going to be A, all right, to sustain the flame. All right. Question number eight. Certain have a beaker of no acid, limestone uh, bubbles vigorously into small bar brimstone lab. All right, limestone is calcium carbonate here, and you place it into acid, it bubbles vigorously. So we have talked about this reaction already, right? Remember this reaction, the double replacement reaction to form calcium chloride, CO2, and water. We have talked about this reaction before. You add some barium nitrate and you form, oh, sorry, you do not use HCl. Sorry, my bad. Because when you add barium nitrate, you form barium sulfate. So basically, you need to have sulfate. All right, you need to use sulfate in this reaction. You need to use sulfate. All right, the acid must have sulfate, so it's going to be sulfuric acid. Sorry, my bad. Question number 8 is going to be C. All right, because in the solution, when you have the reaction between calcium carbonate and the acid, it will give you something that can still give you sulfate when you add barium nitrate as well into the mixture. All right, so the source of sulfates must come from the acid, which is sulfuric acid. Okay, so you have this reaction. Calcium carbonate reacts with sulfuric acid to form calcium sulfate, H2O, and CO2. All right, and you still have H2SO4 that is in excess in the solution. This is in excess, and you still have sulfuric acid there. You add barium sulfate, and then it can give you the white precipitate still. So the next reaction is H2SO4 plus BaCbONO3 2. It's going to be BaSO4 and HNO3. Question number 9. Yeah, question number 9. Mining can provide many useful products. The table lists and describes some common rocks and important historical structures that have been made from this rock, which is list at risk of acid rain damage. Acid rain damage. All right, we need to take a look at the table, right? We need to take at the table. All right, the thing that can react with acid is calcium carbonate. All right, so you read through the information here. Calcium carbonate will give bubbles when it's mixed with dilute acid. So this will be dissolved by acid. The thing that is made from calcium carbonate will be dissolved by acid. But silicon dioxide does not react in acid. So silicon dioxide will not be affected by acid rain, right? We have this rock, and you have to map it to the rock that you have up here and choose the thing that is made from silicon dioxide to confirm that it will not be at risk at acid rain because it does not react with acid in the rain, so it will not be damaged by acid rain, right? So the thing that is made from silicon is granite and quartzite granite. So the red pyramid of Egypt. Question 9 is B. Okay, it's B. Moving on to 15. Oh wait, we have 10. Question number 10. What is unusual compound? Freeze at 0, boil at 100. Um, the If you take a sample of liquid, cool it down, volume decreases until the temperature reaches 4 degrees and it's banned until the temperature reaches 0. It's banned rapidly again at 0 when freezes to I. What happened to the mass of water when it cooled down frozen? To the mass of sample? Well, you have the same sample of water, so the mass will be the same. The volume is different. So the density is different, all right? The volume is different. You have the same mass, but you have different volumes, then the density will be different. However, the mass does not change, all right? You still have the same amount of compound, you have the same substance, therefore the mass does not change. What changes is volume and density, all right? These are the things that we change, but the mass does not change here. So question number 10 is A. Moving on to question number 13. 13 and 14. A piece of wood of mass of 100 grams burned until all remain 5 grams of ash. The rest of the mass of the wood, well, when you burn wood, right, you burn it into CO2 and water and ash. So it will not destroy. You cannot destroy matter. It will just like turn into something else and maybe a gas, and the gas will just fly out, right? So it's going to be A. Question number 13. It will return to some other gases like CO2, like water, and it will be mixed into air. You cannot turn it into oxygen. Oxygen is a thing that you use to burn things. So you cannot basically produce oxygen. And if the rest of the mass is left in ash, then it should add up to the mass of the ash. But no, the mass of the ash is just 5 grams. So it's not going to be left in ash. It's going to be something else that will fly out and you cannot kind of measure. Question number 14. The process of making cheese, I guess, but they are out of order. All right, so we have this process already. So just map it to the image. All right. The first step is to add something called rennet into milk, and then um, solid lumps are formed that I call curd. So add something. So you have two different processes of adding things. Okay, so you cannot answer for now. So let's move on. Draining, you kind of separate words. So it's basically R, right? Very obvious. You add salt to the curd to have it drying. So you see here, use is already kind of like dry, and you add more salt, which is solid. So this is U. So the first one will be S. And ripening is pressed to get the right flavor and consistency. You see, this is pressing. So it's going to be T. So SRUT. SRUT is going to be A. Question number 14 is A. Question number 15. This is the laboratory to separate crust and whey. Where crust and whey. That is basically drying process, right? So it's going to be um filtration. What? So you have a filter, right? You have a filter layer, and you kind of drain it. So basically it's filtration. This is basically filtration. Only water can go through the pores in the filter, but the mass stay inside. So it's filtration. And you choose the system for filtration, which is B. All right. You have a funnel and you have filter paper here. So basically you're gonna drain out the water. Only the water can go through the funnel. So it's gonna be B here. Moving on to the question number 16. 16, 17, 18, 19, 16. 10 grams sample of cheese were placed in drying oven. Next day, the sample were completely dry and weighed 7.7 grams. What cheese type it has? Okay, so you have to calculate the percentage of water that you you have. All right. So 10 grams is the amount of cheese in the first plate, and 7.7 is the mass of like dry cheese. So the difference will give you the mass of water. All right. The difference will give you the mass of water. So 10 minus 7.7 is 2.3. 2.3 divided by 10 multiplied by 100% will give you the percent of water inside. So it's going to be 23%, right? It's going to be 23%. So mapping to the table that we have is the very hard. Wait, let me take a look at the next day. The cheese type, 10 grams of cheese placed in a drying oven. The next day, the sample was completely dry and weighed. What cheese type would likely to be? 10, 7.7, the percentage of water. It's very hard. Oh, okay, let me take a look at the answer. It's very soft in the answer, right? It's weird. Let me double check it again. Oh no, yeah, very hard. Sorry, I look at the wrong column. Okay, that's correct. Okay, so 2.3 is gonna give you 23%. Right, 23% is within the range for the very hard cheese. So let's shoot that. 17. Information here, based on information, which statement is correct? Add water content increases in cheese. Water contain, where's the water contain? Okay, all right. We have to map two different questions here. Um, so yep, you have an increasing order of water contained. More water, total energy increase. Total energy is here. Now, when you have more water, the energy will decrease. All right. So moving on. Water content increases. Total fat increase. No, total fat will go down. So incorrect. Calcium content decrease. Yep, that's correct. And the last one, sodium content increase. No, it will decrease. So C is correct. All right, moving on to question number 18. Firework, red fire is due to. Okay, let's take a look at red fire. We have strontium nitrate, potassium chlorate, charcoal, sulfur. Um, all right, so you need to see the difference between these colors, right? Green, red, and yellow. Choose the thing that is only available in red, but it's not available in yellow, right? Strontium. Okay, I don't see strontium over there. Okay, skip that. Nitrate. Nitrate is also in green, right? So it's not going to be the thing that we responsible for it. Potassium. Okay, I also have potassium in green. Chlorate. I also have chlorate in green. I also have potassium chlorate in yellow. So it's not the thing that we're looking for. Charcoal. I also see something similar in yellow. So charcoal is not responsible for yellow fire. Sulfur. I also see the same thing in green and yellow. So sulfur is not the thing that we're looking for. So it's strontium, right? It's strontium nitrate, especially strontium, because for nitrate part, we can also see the nitrate part in green. So nitrate is not the thing that is responsible. So it's only strontium. Okay. Question number 18 is D. Um, question number 19. This is the structure of protein, um, which is the improved version of the 1990 image of protein. So this is the image of protein. Okay, as you can see here, you have this kind of like helix structure, right? So you need to choose something that has the helix structure. And let's see how many helices do you have? One, two, three, four, five, six, seven. Seven helices. So you have to choose something that also have seven helices. So it's going to be B, right? One, two, three, four, five, six, and seven. All right. Something similar to this. It will have the helices, helical shape like this, but the number of helices must be the same as well. So it's B. All right. Moving on to the question number 20. 20. All right. 20. All right, which is the correct label of structure? Um, okay, read through the question. When water freezes, it's bend and form the three-dimensional crystal, regular hexagon, expansion in the molecular biological molecules, causes it to expand and break the molecule in the living cells. uh, vitrification essentially snap throws water and molecules stopping the water from expanding. So yeah, the first one is just basically the hexagon structure, right? Hexagonal structure of water. So it's frozen water. It's not liquid. Liquid does not have the hexagonal structure, so it's frozen. The second one is that when you have the expansion, it will break. You see here, this is the when you have uh the break in the cell membrane. So that is basically the eye crystal in a cell. And the last one, you do not break the cell membrane anymore. And that is the definition of vitrification in the cell. You stop the eyes from breaking the cells. So it's D. Moving on. Question number 21, 22 as well. Question number 21, we have this information. Which student will have the most salt left over in the beaker once they have dissolved as much as they can? All right, this is the question relating to calculation. Okay. This is the solubility. Um, Solubility will tell you how much salt that you can dissolve. All right, the maximum amount of salt that you can dissolve. And take a look at here. This is the solubility in 100 milliliter. All right, in 100 milliliter. Okay, if your student have the most salt left in the beaker once they have dissolved as much as they can. So in the experiment, you add 30.39 grams salt into the uh into wait, let me read through the question again. Small salt added to water dissolved, more salt added stir, no more salt dissolved. The graph shows the maximum amount of salt that will dissolve at a variety of solution temperature, blah blah. Okay. If more salt is added, it will say in the bottom container is dissolved. For student giving the four separate amount of salt, okay, and you have 100 milliliter water, okay, which still will have most salt left over. It means you cannot dissolve it. All right. Uh, so basically, you need to compare what they have here and the solubility. So you calculate what? You calculate the difference between solubility and the amount of salt that they have here to give you the amount of salt that is left over. Because when you dissolve salt into the solution, you're gonna make sure that you dissolve as much as possible. It means the amount of salt is gonna be corresponding to the solubility. The thing that cannot be dissolved is a thing that is higher, right? The part that is beyond the solubility, so it cannot be dissolved anymore. All right. So the first one is at 20 degrees Celsius. 20 degrees Celsius is here, and the solubility is almost 36. All right, maybe 35 or something. Okay, so 36.5 minus 35, which is the amount that you can dissolve, it will give you around 1.5. So the amount of salt that you have left for the first student is 1.5. 40 and 37.5. 40, 37.5. This is almost 36.5. So 36.5, almost 36.5 is going to give you 1. Jasmine at 60 degrees Celsius. 60 degrees Celsius is here, and it is exactly 37. Now you can dissolve 38.5. So it's 1.5. And at 80 degrees Celsius, which is here, is almost 38. And you can dissolve, you have 39. So 39 minus 38 is going to give you 1. So you have to take a deeper look at these two students. They are almost 1.5. So take a deeper look at them. 36.5. Oh, so 35 is down here. Sorry, this is not 0.5. It's gonna be 35.5. Sorry, 35.6 or something. It's gonna be 0.4 or something. It's gonna be higher than 30 here. It's gonna be almost 36. Sorry. So it's almost 36. So we we the mass here is almost 0. Sorry, my bad. I I saw the wrong number. It's almost 36. So 36.5 is here minus this much is going to be almost 0.5. All right. maybe 36, and it's going to be almost 0.5. So the answer here is jasmine. Jasmine can have 1.5 grams of salt left. So let's see. Question number 22. Chris let the solution cool down to 20 degrees Celsius. The amount of salt that was undissolved grew at the bottom. All right, Chris is here. Let the solution. Okay, so Chris already have the solution. So solution is the thing that is in the solution. So we ignore the amount of salt that is left in the first place. We just need to take into consideration the amount of salt in the solution for now. So Chris is at 80 degrees Celsius here. And at 80 degrees Celsius, you have 38 grams of salt. And then you cool it down to 20. So it's going to be almost 36. The difference from 38 to 36 is going to be roughly 2 grams. Oh, sorry, it's roughly 2 grams, all right? But you also need to take into consideration the amount of salt that you have in the first place as well, because let the solution cool down and then, you have more undissolved salt at the bottom. Sorry, my bad. So it means you also need to take into consideration the amount of salt in the first place, well, which is almost 1 gram. All right. So you can collect 2 more grams of salt, separating from the solution when you lower the temperature. All right. When you lower the temperature, the solubility will decrease from here to here. So that range will be corresponding to 2 grams. And in the first place, when you dissolve 39 grams of salt into the solution, you have 1 grams of salt left in the solution. So 2 plus 1 that is already in at the bottom of the beaker. So total is going to be 3. And you're going to choose the thing that is closest to 3, which is 3.2. So question number 22 is B. All right. Moving on to the question number 23. Um, this is the what we call the heating curve. I already talked about this before, right? Section B has what? B is this part. So the first part is just solid. M is gonna be when you have the oh, sorry, this is the graph of many different gases at the same time. Of many different gases at the same time. Okay. So we liquefy these gases and then you will heat up the temperature gradually. So at first, what you can collect is nitrogen, right? What you can collect is nitrogen because this has the lowest boiling point. So when you heat up gradually, say we'll come to the boiling point of nitrogen first. So in this region, you have nitrogen, you have argon, you have oxygen. But after M, when you kind of like convert all of the nitrogen back into gases. So after M, at N, you have just argon and oxygen. So moving on, we come to this. We keep increasing the temperature, so you're gonna come to the boiling point of argon. So at at P, all right, at P, you only have liquid oxygen, right? You don't have liquid oxygen. So it's going to be B. 23 is B. All right. Because when you increase the temperature, nitrogen will convert, we can convert from, we can convert it from a liquid into a gas. And you keep doing so, and you eliminate nitrogen first, and then argon, and then in the end, you just have oxygen. Question number 24. Technician analyzing some water. We have this information here. Sulfuric acid is, oh, wait, sorry. Mass of soluble material, mass of insoluble material. He collect 50 milliliters of water, separate into 2 different samples. Filter the sample, evaporate, weight the dry solid residue from each beaker, each sample. Found out the mass of solid filter in the sample was 40 grams. The mass evaporated sample was 55 grams. Okay, Here's the thing. This is from just 200 milliliters of sample, right? 40 grams here is just corresponding to 250 milliliters of sample. Because in the first plate, you collect 500 milliliters, but you separate this sample into two different samples. All right. And then for one sample, you do the experiment and you get 40 and 55. So 40 grams here will be corresponding to only 250 milliliters of sample. 55 here is only corresponding to 250 milliliters. Now you are asked to answer for 1 liter. Okay. You are asked to answer for 1 liter. So you multiplied it by 4, right? Okay, so multiply by 4. So 40 multiplied by 4 is going to give you 160. 55 multiplied by 4 is going to give you 220. Okay, 220. All right, let's read to the question one more time. Um, the mass of the solid in the filter. Basically, he filtered one sample, evaporate the other sample. All right. So the mass of the solute in the filter sample is 160 grams. So when you filter, the solid that you can collect is the mass of the insoluble material. All right, so it's going to be 160. So how do we calculate the mass of the soluble material? So just take the total amount of mass of a solid, right? When you kind of like evaporate all the water, what you have in 220 grams is the insoluble amount of solid and also the soluble amount of solid. All right, both of them. And you know that the amount of insoluble is 160. So take 222 minus 160, and it's gonna give you 60. So the answer here is C, 24C. 25, 24, 25. Let me take a look. Oh, we need to also question number 20. Oh, 22 is already answered. 25. Okay, 25. Basic building blocks of chemistry, atoms, elements, join to form molecules. A compound is a substance that have two or more elements chemically joined together. Okay, which of the following is true? The sample only contains three different types of atoms. Um, three different type atoms. We have oxygen and we only have sulfur. So two different types of atoms, not three. The sample only contains three atoms. No, not three atoms. We have more than three atoms. Um, atom is like one thing like this. For example, like for oxygen, you're gonna have two oxygen atoms. Okay, but obviously you see that we have more than one atom, so more than three atoms. So it's not correct. Molecules of elements. No, we have molecules of compounds as well, like sulfur trioxide and sulfur dioxide. They are compounds because they have two different elements going on in one substance. It contains two compounds. Yes, it contains two compounds. Oxygen is one element. Sulfur dioxide and sulfur dioxide two compounds. We have three substances, one element, and two compounds. Okay, so this is correct. Moving on to the question number 26, 26, 27, 29, and 30. All right, 26. Based on the information here, which does not correctly list one reactant and one product. Um, one reactant and one product. Reaction. We have to use the information in question number 25 and 26. Okay. In reaction one, reactant is sulfur. Sulfur is react with oxygen to form sulfur dioxide. Okay, that's correct. Sulfur react with oxygen to form sulfur dioxide. Okay, correct. So sulfur is the reactant and sulfur dioxide is the product. Second process, sulfur dioxide let react with oxygen to form sulfur trioxide. Yep, trioxide is not the reactant. This is not the reactant. It's the other way around, so B is incorrect. Moving on, mixing sulfur trioxide with water, we have oleum. So it's correct. Sulfur trioxide, oleum. Sulfur trioxide is the reactant product, is the oleum. That's correct. Oleum, and you mix it with water to have sulfuric acid. So oleum is the reactant and product is sulfuric acid. That's correct. So B is incorrect. You have to swap these two positions together. Moving on to question number 27. Half-life is the every 6 hour half of the technetium will be decomposed, and then we have just half of the amount of technetium. So if you have 160 milligrams of technetium after 18 um, after 18 hours, so what mass would remain? All right, so take a look at the diagram here. From 8 after 18 hours, you probably have just one, right? You probably have just one milligrams. From 8 milligrams of technetium after 8 hours, after 18 hours, you only have one. So from 8 to 1. So if you have 160, you divide by 8, all right? You divide by 8. So you probably have 20 milligrams of magnesium left. Mhm. The other way that you can do is like this. Every 6 hours, the amount of technetium will be reduced by half, right? So it's going to be, so for 18 hours, it will reduce by half 3 times, right? 6 hours, it reduced by half one time. So 18 hours will be reduced by half 3 times. So you just take 160 divided by 2 to the power of 3 because you reduce by half 3 times. And it's to give you 20. All right, so there are two different ways for you to do the question. Moving on to the question number 28. We have this molecule over here. What is the chemical formula of vitamin B12? This is easy, right? You already have the number of phosphorus, nitrogen, oxygen, or something like that. One cobalt will give you one phosphorus, so COB. 14 nitrogen will give you one phosphorus, so it's going to be N14. One oxygen for every nitrogen. So you have 14 nitrogen, so you have 14 oxygen as well. 63 carbon for one cobalt, so C63. 25 hydrogen more than the number of atoms of carbon, so just add 25 to it. H 85. Yep. So just choose the thing that has the, oh, sorry, 88, my bad, 88. 63 plus 25 is going to be 88. All right. So just choose the thing that is corresponding to the thing that you have here. So question number 28 is going to be 8. All right. Do the comparison and you see that it's actually 8. Question number 29. 20 micrograms of B12 per week. Vitamin can be found in different type X. This X. Which of the following combination will supply a weekly dose of vitamin B12? So a weekly dose of vitamin B12 will be 20 micrograms, right? Right. And all right, for duck X, 4 of duck X is gonna give you 16 milligram, which is not enough. 2 duck X and 10 quail X. Quail X is here, multiplied by 10, 0.5 multiplied by 10, and 2 duck X, which is 4 multiplied by 2. So it's going to be 5 plus 8. It's not enough. No. 20 chicken X. Chicken X is here. 0.5 multiplied by 20. It's going to give you just 10 milligrams, which is not 20 just 10 micrograms, which is not enough. 3 goose eggs. 3 goose eggs. 7 times 3. It's going to be 21. All right. This is above the amount of vitamin B12. Okay. So it's enough. All right. It's more than enough. So it's going to be D. All right. The last one. The name of the element is what? You have to do the crossword. Uh, food that can be made from crust. Um, complete the crossword. The first letter down the column will form the important element as a vitamin. Um, food that can be made from crust is cheese, right? Cheese. Component of air that is needed to burn fire is oxygen. Sea salt concentration. Sea with a salt concentration of um 10 grams per liter. Sea um it's gonna be Baltic, I guess. I'm not sure. Maybe it's Baltic. Maybe I'm not sure. All right, for that one, I'm not really sure. But I think with this high amount of of um of salt, it's gonna be Baltic. But if you don't know, just keep it. Gas mixture that we breathe is air. State of water at 25 degrees Celsius is liquid. Number of elements in water molecule is two, right? We have hydrogen and oxygen. So it's going to be cobalt, which is the element that we need to fight. That's it for today. Three different mock tests. All right. If you have any more questions regarding all these things that we have talked about, um, let me know. All right. I'm also gonna send you the files here, so that you can take a look at the all the answer that I have already showed. All right. That's it for today. Thank you, guys. If you have more questions, send me a message into Dialog. All right. That's it. See you guys.
Thank you, teacher. Goodbye, teacher.
Thank you.